let's discuss about the t distribution, which is of method 2. In the previous video we have discussed about the method 1, but now we shall discuss about the method 2. So this method 2 is the test of significance for difference of means. So in the method 1 we have seen only one normal population, so where that normal population has n number of sample sizes and x bar is the mu and sigma is the standard deviation and etc, because we are having only one normal population. But in the method 2 here we will have the two normal populations where each normal population has n number of samples and x bar mu and then standard deviation. So here in the method 1 we was having only one normal population. Now in the method 2 we will have the two normal populations. So let this be as first normal and the second normal population. Now for the first normal population we will have the sample sizes, mean, population mean and standard deviation. So those are denoted by n1 nothing but it is a sample size and x bar is the mean sample mean and mu1 is the population mean, and then the s1 nothing but the standard deviation of the first population. And similarly for the second normal population also we will have these four terms. So we are representing those as n2 and the sample mean as y bar and the population mean as mu2 and the standard deviation as s2. So in the method 2 we will have the two different normal populations. So that's why this is the test of significance for differences of means. So we will compare the mu1 and the mu2. So in this method 2 we will compare the mu1 and mu2, nothing but population mean of the first normal population and population mean of the second normal population. And let's see first a procedure for test of significance for differences of mean. So we'll have one procedure, as in the method 1 also we have seen a procedure. This procedure is very important because in all the problems we will follow only this procedure. And if you like my content, please do subscribe to my channel. The first one, so here also we will have the same 5 terms: null hypothesis, alternative hypothesis, level of significance and test statistic, and finally we will have the conclusion. So in the null hypothesis we will compare the population means of two different normal populations. We know population mean is represented with the mu, but the first normal population mean is mu1 and the second normal population mean is mu2. So this is there in the null hypothesis we will assume that there is no significance difference between the population mean of the first normal population and population mean of the second normal population, nothing but we are assuming that both the values are equal. So that is h0 is such that mu1 is equals to mu2. So this is a statement you have to write. No need to write the matter. If you write this statement, then it is enough. So that is h0 is such that mu1 is equals to mu2. It means we are assuming that there is no significance difference between the first population mean and the second population mean. And next we are having the alternative hypothesis. So this is represented with the h1. Now this alternative hypothesis is nothing but it is complementary to the null hypothesis. In null hypothesis we will assume that there is no difference, but in the alternative hypothesis we will assume that there is a difference between the mu1 and mu2. So when there is a difference, nothing but both the values may be not equal, and maybe mu1 is less than mu2 and it can be mu1 greater than mu2. So for all these cases, when mu1 is not equals to mu2 we will say it as two-tailed test. When mu1 is less than mu2 we will say it as left-tailed test, and when it is mu1 is greater than mu2 then we say it as right-tailed test. We can solve the problems by using two-tailed test, and these two-tailed tests are called as the one-tailed test. Again in the one-tailed test we will have the right-tailed test and the left-tailed test. So we can solve the problems by using two-tailed test or by using the one-tailed test. So in the two-tailed test, in the level of significance, we will take the alpha as alpha by 2. So we will take alpha as alpha by 2. But in the one-tailed test, we will take only the alpha value directly. As I told you in the previous class also, in the when we are finding out in the t distribution and in under the two-tailed test condition, the alpha is considered as the alpha by 2 value. If you want to solve any problem by using one-tailed test, then directly you have to take the alpha value. So let's understand about this very briefly. Now in third, we are having the level of significance. So in the level of significance, we will calculate the table value. So to get the table value, first the alpha value will be taken. So alpha can be 1% or it can be 5% or it can be 10%. But in the problem, if they didn't mention any alpha value, you have to consider it as 5% only. But if they give the value, then you have to take the value as a alpha. But if they don't mention, then you have to take it as 5%. This is a standard alpha value. So for in general, alpha percent is alpha by 2. So for example, I am taking the alpha percent as 5% because in all the problems we will take the alpha as 5%. But we know that in the t distribution under the two-tailed test condition, we will take the alpha as alpha by 2. Now when I divide this 5%, so in the generally we will take alpha as 5%. So for the two-tailed test, as I told you before, all the problems I am solving here, those are under the two-tailed test condition. If you want, you can also try for the one-tailed test also. Now the alpha by 2. So alpha by 2 nothing but it is 5% divided by the 2. So which gives the value as 0.025. Now this alpha by 2, 0.025, we are considering it as alpha. So when we are finding out in the table, table value from the table, we have to take this 0.025 as the alpha. And then with the degree of freedom n1 plus n2 minus 2 degree of freedom. So in the method 1, we was having only the one normal population. So at that time the degree of freedom was nu is equals to n minus 1. In the one, because we are having only the one normal population and that normal population has the n number of samples. So nu will be n minus 1. But coming to the method 2, we will have the two different normal populations where the first normal population has n1 number of samples and the second normal population has n2 number of sample sizes. So the degree of freedom also changes. Now in the method 2, the degree of freedom nothing but mu is equals to n1 plus n2 minus 2. So this is the formula we will use in the method 2. Because we will have the two different normal populations and two normal population has the different sample sizes. So those are represented as n1 and n2 respectively. So the normal degree of freedom is mu is equals to n1 plus n2 minus 2. So this is the formula we will use. So in general, alpha percent is alpha by 2, that is 0.025 with n1 plus n2 minus 2 degree of freedom. Now by based on the alpha value and based on this degree of freedom mu value, we will find out the table value. So this is under the level of significance. Then we are having the test statistic. So in the test statistic, under the null hypothesis, the test statistic is given by the formula, that is the calculated t value is x bar minus y bar divided by s into under the root of 1 by n1 plus 1 by n2. So this is the formula we will use under the test statistic. So under null hypothesis, this is the formula to find out the calculated t value. And when the samples means x bar, y bar and a standard deviation are not given directly. So here the n1 is the sample size of the first normal population, n2 is the sample size of the second normal population, x bar is the sample mean of the first normal population and y bar is the sample mean of the second normal population. And here s is the calculated standard deviation value. So this standard deviation sometimes it will be given directly in the problem and x bar, y bar will also be given directly in the problem. But when the s, x bar and y bar is not given directly in the problem, then you have to use these formulas. So those are, so you can see a statement here, when sample means x bar and y bar and the standard deviation s are not given directly, then these formulas we have to use. So for x bar, so to find out the x bar, compulsorily in the problem the observations will be given. So number of observations will be given and those observations also will be given. So at that time you have to use a formula as summation of xi by n1. It means sum of all observations by the number of sample size, you can say, number of observations. So this is to find out the sample mean, that is x bar. And obviously we will have the second observation also, which is to find out for the y bar. So sum of all observations of the second sample or second normal population divided by the sample size of the normal population, that is n2. So these are used to find out the x bar and the y bar. And we are also having a term, that is standard deviation. So standard deviation we will represent it with the s. So that is equals to under the root of sigma of xi minus x bar whole square plus sigma of yi minus y bar whole square divided by n1 plus n2 minus 2. So this is the formula we will use to find out the standard deviation. So in the previous also, in the method 1, we were, whenever the observations was given, to find out the standard deviation we was using one formula, that is standard deviation is equals to under the root of sigma of xi minus x bar whole square divided by n minus 1. So we here n minus 1 nothing but it is the degree of freedom. And this sigma of xi minus x bar whole square, sometimes it will be given in the problem as sum of the squares of the deviations from the mean. So like that it will be given, or it can also be given the number of observations and the observations. So at that time the standard deviation we will use the formula as under the root of sigma of xi minus x bar whole square divided by n minus 1. So this is in the method 1, because we are having only one normal population and one single mean and single sample size. But here in the method 2 we will have the two normal populations. So for that we are using the standard deviation formula, which is represented as s. So that is under the root of sigma of xi minus x bar whole square. So this is the sum of the squares of the deviations from the mean of the first normal population and plus sigma of yi minus y bar whole square. So this is the sum of the squares of the deviations from the mean of the second normal population and divided by the normal degree of freedom, that is so this square root is for both numerator and the denominator. So degree of freedom is n1 plus n2 minus 2. So this is a standard deviation formula we will use to find out the s. So these are some of the important formula. So whenever the x bar, y bar and standard deviation values are not given directly in the problem, then these formulas will be helpful. So this is under the statistic and this formula is important. Now finally we are having the conclusion. So in the conclusion we will compare the calculated t-value and the table value which we got in the level of significance. So if calculated t-value is less than the table t-value, we will accept the null hypothesis. Nothing but we will accept not. So whenever the calculated t-value is greater than the table t-value, then we will reject the null hypothesis. So these are the two conditions we are having. So we have to compare both the calculated t-value and the table t-value. So this comes under the conclusion. So we have one statement here. Students t-test for difference of means at x bar and y bar, means of two independent samples of size n1 and n2. So where n1 is less than 30 and n2 is less than 30. So that is, so we are doing the t distribution. We know that in t distribution the sample size will be less than 30. And whenever the sample size is greater than 30, it means when the sample size is larger sample, then we have to use the z distribution. So in all the problems we can find that the sample size will be less than 30. So that's why for n1 and n2 values will be always less than 30 when we are finding out in the t distribution values, t distribution table values. Of samples of sizes n1 and n2 where n1 is less than 30 and n2 is less than 30 are drawn from two normal populations having means as mu1 and mu2 to test whether the two population means are equal or not. So here why we are using this t distribution method to nothing but, so here this is for the differences of means and x bar and y bar at the means of x bar and y bar means those are of two different independent samples, nothing but two different normal populations. Those are having the sample sizes as n1 and n2 and the two normal populations are having the means as mu1 and mu2. So to test whether the population means are equal or not, we will use this t distribution case under the method 2. So let's solve some of the problems on this method 2. Samples of two different types of electric bulbs were tested for length of life and following data were obtained. So in notional you can observe that two types of electric bulbs, not the two normal populations you can take. So whenever you see like this two type of electric bulbs or two different, then you have to follow the method 2. So here the type 1, it means the first type of electric bulb. Further the sample size is n1 that equals to 8 and the mean x bar is equals to 1234 hours and the S1 nothing but the standard deviation of the first type of electric bulb is given as 36 hours. So you can take this as small s, because in the test statistic we will find out the capital S. So that capital is nothing but overall standard deviation. So it's better to take here s1 and small small s2. And in the type 2, nothing but the second type of electric bulbs are having the sample size n2 is equals to 7 and the mean y bar. So these mean are nothing but sample means. So sample mean y bar is equals to 1036 hours and the standard deviation of this second type is 40 hours. So this is the given information. So each the difference in the mean sufficient to variant types type 1 is superior to type 2. So according to the length of the life. So this is the given information. So first write the given data, that is the sample sizes for the type 1 and type 2. n1 is equals to 8 and n2 is equals to 7 and x bar is equals to 1234 hours and y bar is equals to 1036 hours. And S1 is given as 36 hours and S2 is 40 hours. So first the null hypothesis. In this null hypothesis we will assume that there is no significance difference between the population mean of the first normal population, nothing but first type of electric bulb, and the population mean of the second type of electric bulb. So that is mu1 is equals to mu2. And in the alternative hypothesis, as I told you before, we are using the t distribution under the two-tail test condition. It means mu1 is not equals to the mu2. So in this alternative hypothesis, it is a complementary to the null hypothesis. In this, we will assume that there is a significance difference between the mu1 and the mu2. And this is under the two-tail test condition. Now, in the level of significance. So in the level of significance, in generally we will take the alpha as 5% because they didn't mention any value, any percentage value in the problem. So we will take the alpha as 5%. But now under the t distribution condition, under the two-tail tester, we have to take alpha as alpha by 2. So nothing but 5% divided by 2 is equals to 0.025. Now this is the value for the alpha. Though we are finding out the alpha by 2, but finally we have to take 0.025 as alpha value only. Because when we are finding out the value from the table, we will check only the alpha values. The alpha by 2 values will not be given. Only alpha values will be given. So from that alpha values only we have to find out the 0.025. So this is under the two-tail test condition, we will take the alpha by 2. Now this is with nu is equals to n1 plus n2 minus 2 of degree of freedom. So n1 is 8 plus n2 is 7 minus 2 equals to 13 degree of freedom. So now from the table we have to find out the table value. Table is here. So degree of freedom. As I told you, but the first column will represent the new values, nothing but represent of freedom values, and this first row values are nothing but the alpha values. So as I told you, alpha will be taken as alpha by 2 in the t distribution under the two-tailed test condition. So now from this, the alpha by 2 value nothing but we got it as 0.025. So it means indirectly we are saying that it is an alpha value. So the 0.025 is here, and the degree of freedom nu we got it as 13. So the value is 2.160. So this is the value when the degree of freedom is 13 and when the alpha value is 0.025. So it is 2.160. Now this is the table value. You can represent this table value as T alpha value, because based on the alpha value only we are finding out the value for T. So the T table is equals to 2.160, nothing but it is an alpha value. It is an T alpha. Now in the note point also you can see, so the given table values for of T for one tail test. In the one tail test either it can be left tail or the right tail. So if we have to find out the values for of T for the two tail test at any level, then we will take the value of alpha by 2 for alpha. It means instead of taking alpha, we will take the alpha by 2 for the two test under the two tail test, for the t test under the two tail test condition. So the example is also given here. T at a 5% level. So 5% level nothing but we will do the alpha by 2. So 5% divided by 2 nothing but it is same as 0.025. Now with the degree of 9 degree of freedom. So this is a 9 degree of freedom and the alpha value 0.025. So the value is 2.262. So this is the alpha. In the subset we are writing 0.025 nothing but it is an alpha value. So that is 2.262. And similarly the another example is also given here. So for the 2t test under the two tail test condition, we will take alpha as alpha by 2. Now we got the table value. Now we have to find out the test statistic, nothing but calculated t value we have to find out. So under the null hypothesis, the test statistic is given by the formula, the calculated t is equals to x bar minus y bar divided by s into under the root of 1 by n1 plus 1 by n2. So this is s into, you can take this as capital S, because in the given information we were having the two different standard deviations for two different type of the electric bulbs. So the first, this s bar s is this is nothing but it is a standard deviation. Now to find out this value we are having a small formula. So that is, in the previous also we have seen one formula for the to find out the standard deviation, that is under the root of sigma of xi minus x bar whole square plus sigma of yi minus y bar whole square divided by n1 plus n2 minus 2. So that formula we will use when the observations are given. Nothing but when we know the values of sigma of xi minus x bar whole square and the sigma of yi minus y bar whole square, then we can use that formula. But we don't know that formula here. So for that we know only the values of s1 and s2, n1 and n2. So to find out this s value we are using this formula. So s square nothing but it is in a variance. So for this variance the formula is given as n1 s1 square plus n2 into s2 square divided by n1 plus n2 minus 2. So this is to find out the variance. Now after getting the variance we will send the square onto the right hand side, then it becomes the square root. Then we will get the s value nothing but it is in a standard deviation value. Now substitute the values here. 8 into 36 whole square plus 7 into 40 whole square divided by 8 plus 7 minus 2. So s square is equals to, the value we get it as 1659.07. So this is the s square nothing but it is in a variance. Now to get the standard deviation we will just square root the value of variance, or you can send this to this power onto the right hand side, so it becomes the root. So s is equals to root of 1659.07. so this value we get it as 40.73. so this is an s value. Now the calculated t value, so in that substitute the values here. So this is a capital S. Now the values here, x bar minus y bar nothing but 1234 minus 1036 divided by 40.73 into under the root of 1 by 8 plus 1 by 7. So this value we get it as 9.37. So the calculated t value is 9.39. It is a 9.39. So this is the calculated value. Now we are having the conclusion. So in conclusion, we will compare the calculated t value and the table t value. So calculated t value is equals to 9.39 and this is greater than the table value, that is 2.160. So 9.39 is greater than 2.160. So in this case, we will reject the null hypothesis, nothing but we will reject the H naught. So this is how we solve the problem. The important thing is the using the formula, that is s square is equals to n1 s square plus n2 s square by n1 plus n2 minus 2. So that is the important problem, because by the in the question itself, the whatever the information is given, based on that you have to use the formula to find out the mean, or nothing but to find out the sample means, or to find out the standard deviations. So that understanding the question is very important here. So that is one type of question which is based on the formula s square is equals to n1 s square plus n2 s square n2 s2 square by n1 plus n2 minus 2. So in that question the sample sizes are given, the mean x bar and y bar are given, and the sample standard deviations for each of the two different types are given. But in the test statistic we will use the formula as calculated t is equals to x bar minus y bar by s into under the root of 1 minus 1 by s1 plus 1 by s2, 1 by n1 plus 1 by n2. So there we are using the capital S. That capital S is nothing but it is in a standard deviation of the overall electric bulbs, overall two types of electric bulbs. But in the question they given it as separately. So by using the formula we can find out the capital S. So that understanding the question, understanding the problem is very important. Now we'll also solve another different type of t distribution on the method 2. The mean of two random sample of sizes 9 and 7 are 196.42 and 198.82 respectively. So here in the question itself you can understand means of two random samples. So two random sample nothing but we are having a two normal populations. So whenever the two normal populations are given, we have to use the method 2. And the sample sizes for each sample or each normal population are also given as 9 and 7, and the means are given as 196.42 and 198.82 respectively. So nothing but n1 is 9, n2 is 7 and x bar is 196.42 and y bar is 198.82. So means are given and sample sizes are also given, and the sum of the squares of the deviations from the mean are 26.94 and 18.73 respectively. So whenever we see this respectively, the first one is for the first normal population and the second one is for the second normal population. So the word respectively means just we have to take first value for the first normal population and the second value for the second normal population. So means sizes are given, sample means are given, and here they gave it as sum of the squares of the deviations. So as I told you in the previous, sum of the squares of deviations nothing but it is in a sigma of xi minus x bar whole square. From the mean, we are the deviations from the mean nothing but xi minus x bar. From each of the observation, after subtracting the mean and after doing the square, after adding and after doing the square, those values are given as 26.94 and 18.73. So indirectly sigma of xi minus x bar whole square is 26.94 and sigma of yi minus y bar whole square is 18.73. So these values are given. So can the sample be considered to have been drawn from the sample from the same normal population or not? This we have to find out. So as I told you, there are two normal populations. Nothing but it can be the one normal population in the from one normal population itself, the two random samples are taken, or it can be given as two different normal populations. Both the mean same. So drawing two balls from one box is same as drawing the one drawing the different balls from two different boxes is different. So both nothing but it is same, but here the normal population we are having the, it's just we have to check that these both random samples are taken from the same population normal population or not, because they gave it as only two random samples, just the two times they are drawing, but we have to check that both whatever we are drawing the two samples, those are given from the same normal population or not, just we have to find out. So for that we are using the t distribution under the method 2. So method 2, because it is in a drawing two times, so two random sample sizes are given here. So sizes are given, sample means are given, and some of the squares of the deviations from the mean are also given. So first write the given information. So sample sizes n1 is equals to 9, n2 is equals to 7, and x bar is 196.42 and y bar is 198.82, and it is also given that sum of the squares of the deviations from the mean are given as 26.94 and 18.73. So it means sigma of xi minus x bar whole square is equals to 26.94 and sigma of yi minus y bar whole square is equals to 18.73. Now based on the given information we have to find out the standard deviation. So in the problem the standard deviation s value is not given directly. So we have to find out the standard deviation, that is s. Now the information which we have in the which is provided in the problem is only the xi minus summation of xi minus x bar whole square and summation of yi minus y bar whole square. So previously also I have told you, based on the information itself we have to understand the which formula has to be used to find out the standard deviation. Now I'm having the square sum of the squares of the deviations from the mean for the both the two different random samples. So I can use the formula as s square is equals to sigma of xi minus x bar whole square plus sigma of yi minus y bar whole square divided by the n1 plus n2 minus 2. So this formula I have told you while explaining you the procedure for the method 2. So now we are using this formula because the values are given in the problem. Now substitute the values. Here s square nothing but it is in a variance. After that we can find out the standard deviation very easily. Now the substitute the values here, 26.94 plus 18.73 divided by n1 plus n2 minus 2 nothing but 9 plus 7 minus 2. So s square is equals to 3.26. So this value we get 3.26. Now send the square onto the right hand side, it becomes square root. So s is equals to square root of 3.26. So s is equals to 1.80. Now we got the value of s. So this is nothing but it is in a capital S. What we are finding, these all are nothing but it is a capital X, because in the test statistic the formula will be calculated t value is equals to x bar minus y bar by s into under the root of 1 by n1 plus 1 by n2. So there s nothing but it is a standard deviation for overall two random samples. So that's why we will consider the capital S. So whenever in a problem two different standard deviations are given for two different random samples, then we take it as small s1 and small s2, because to not get confused we will use the small s1 and small s2, and in the formula we will use same as capital S. Now we got the capital S, that is 1.80. Now the process is to check whether the two random samples are drawn from the same normal population or not. So first the null hypothesis, we know that we will compare the population of two different samples, population mean of the two different samples, that is mu1 and mu2. So in this case we will compare the mu1 and mu2 So it means there is no significant difference between the population mean of the first sample and population mean of the second sample. So this is another null hypothesis. H0 is such that mu1 is equals to mu2. And in the alternative hypothesis, we will assume that there is a significance difference between the mu1 and mu2. So that is mu1 is not equals to mu2 under the two-tailed test condition. So as I told you before, you can also use the one-tailed tester. If you use one-tailed test, the alpha value will be taken as directly as alpha only. But in the two-tailed test, we will take alpha as alpha by 2. So it's very easy to use the two-tailed test condition. Both the values, when we use two-tailed or when we use the one-tailed, both the values will be same. But using the two-tailed test is very easy, because in the one-tailed test you have to check whether the mu1 and mu2, we have to assume as mu1 is greater than mu2 or mu2 is less than mu2. So like that we have to check in the one-tailed test. But in the two-tailed test, just no need to check, just we have to take alpha as alpha by 2, and with the condition is mu1 is not equals to the mu2. Now next, the third is level of significance. In the level of significance, we will find out the table value, nothing but the alpha t value. So in general, alpha is 5%. So in the problem also they didn't provide the percentage value. So the by the standard alpha value, we will take it alpha as 5%. Now we know that we are using the t distribution under the two-tailed test condition. So under the two-tailed test condition, we will take alpha as alpha by 2. So alpha by 2 is equals to 5% divided by 2. That value we get it as 0.025. Now this is an alpha value. It is with nu is equals to n1 plus n2 minus 2 degree of freedom. That is 9 plus 7 minus 2 is equals to 14 degree of freedom. It means alpha 0.025 with 14 degree of freedom. That value we get it as 2.145. So from the table we have to find out this t value. So we can take the t table, or instead of that you can take the alpha t value. So alpha t value nothing but based on the alpha value we are finding out the value for the t. So now from the table we have to find out. So 14 is the degree of freedom, 0.025 is the alpha value now. Now from this table we know that first column will represent the new value, nothing but it represents the degree of freedom. And this first row, whatever these values are there, this represents the alpha values. So alpha value we got it as 0.025 and the degree of freedom is 14. So when you check here, the value is 2.145. So this is the value when the degree of freedom is 14 and when alpha value is 0.025. So it is 2.145. Now the table t value is 2.145, nothing but it is an alpha value. So this is under the, we will do this under the level of significance. It means we are checking the level for the t test. Now the next we are having test statistic. Under H naught, nothing but under the null hypothesis, the test statistic is given by the formula, that is calculated t value is equals to x bar minus y bar by s into under the root of n1 n by n 1 by n1 plus 1 by n2. Now this is the formula given. Substitute the values here. 196.42 minus 198.82 divided by 1.80 into under the root of 1 by 9 plus 1 by 7. So this value we get it as 2.64. So calculated t value is 2.64. It is under the test statistic. Now finally we are having the conclusion. In conclusion we will compare the calculated t value and we will compare the table t value. So the calculated t value is equals to 2.46 and this value is greater than the table t value, that is 2.145. So you can observe these values. 2.64 is greater than 2.14. It means calculated t value is greater than table t value. So if it is greater, then we will reject the H naught. Nothing but we are rejecting the null hypothesis. So this is how we solve based on the given information in the problem. So everything depends on the way you understand the problem and the formula which you have to use in the problem. So the formulas are very important. So this is another different type of the formula to solve the t distribution of the method 2 type. We should also solve some other different types of t distribution on this method 2 in the next section. And if you have any doubts, you can post it in the comment section.